Hello, good day viewers. Hello, welcome. Into this tutorial, we are going to be solving this beautiful, problem here. So we are given x root of 1 over 9 minus 6 equals x root of 1 over 3. So we want to know the value of x. So now from here, now I'm going to do the rearrangement, okay, by taking this to this side, okay. Then I take 6 to the other side. So I'm going to be having right. So from here, so what's the next thing we're going to do? So the next thing we're going to do is that you know that when you have from the law of this one, you have something like roots, let's say root n, okay, a. So this is going to be a raised to power 1 over n, okay, because the root return to the fractional index. So the same thing we are going to do here. I'm going to have 1 over 9, okay, square root of 1 over x minus 1 over 3, then 1 over x equals 6. Are you following? So now from there, the next thing we are going to do, so this 1 over 9, I can rewrite 1 over 9 as 1 over 9, can be written as 1 over 3 raised to power 2, right? At the same time, so you can have it as 1 over 3 all raised to power 2. So which is telling us that when you have 1 squared, you're going to have 1. 3 squared, you're going to have what? 3 squared, which is 9. Then from there, so we're going to replace this 1 over 9 by 1 over 3. So this is going to be 1 over 9, right? 1 over 9. 1 over 9, sorry, I have 3 here, 1 over 3 all squared. I have the power 1 over x here before, 1 over 3, 1 over x equals 6. So now the next thing you're going to do, so please, this is 1 over 3 here, 1 over 3. So now what we need to do next is we're going to apply one of the laws of indices that say when you have a to power b, then another power c, so we can interchange the powers so that c will come inside and the b will go outside. So the same thing we are going to do here, we're going to interchange these two exponents. So 1 over x will come inside and 2 will go outside. So this is what we have, 1 over 3, right? 1 over x, then I have 2 going outside, then minus 1 over 3, then 1 over x equals what? Equals 6, right? So the next thing we're going to do from there is we can see that this and this are the same, so we can say let k equals 1 over 3, then 1 over x, right? Then from this equation now, anywhere we see 1 over 3, 1 over x, we replace it with k. So now when you come here, you see that we have k all squared minus k. Then this is here, let me bring it inside to this left hand side, minus 6 equals 0, right? So from there, so the next thing we're going to do is, so we move on, we have s squared minus k minus 6. So from there, so the next thing we're going to do, we can see that here we can factorize this by having k in this form equals 0. So we're going to look for the two factors that when you multiply them together, you're going to have minus 6, but when you add them together, you're going to have minus 1k, because there is 1 here hidden, okay? So now from there, what are we going to do? So we can see that the value we're going to have is minus 3 and what, and plus 2. So minus 3 times plus 2, we're going to have minus 6. Then minus 3 plus 2 plus 2, we're going to have minus 1k, right? So we move on by equating k minus 3 equals 0, then k plus 2 equals 0, right? So from there, you can see that we have the two solutions. This will be k equals 3, then k plus 2 equals 0, so k equals minus 2, right? So if k is minus 2 there, but don't forget that we are not looking for the value of k, so we are looking for the value of x. So now let's recall that we have k to be equals 1 over 3 to power 1 over x. So therefore here, because k is equals to 1 over 3 to power 1 over x, so it shows that k must always be greater than or equals to 0. Okay, so now from there, if you want to pick the value of k, so the value of k here will be rejected because this one is negative, so we're going to pick this one. So we're going to have k, that is when k is 3, so replace k here. We're going to have what? We're going to have k to be 3 equals 1 over 3 raised to power 1 over x, right? So from there, so the next thing we're going to do is that I'm going to rewrite this 1 over 3 in index form as 3, okay, equals 3 to power minus 1, okay, 1 to power 1 to power 1 over x, right? So now from there, what am I going to have? You see that I'm going to be having this to be, it's going to be 3 equals, we have this to be 3. This negative sign will multiply the outer power. We're going to be having minus 1 over what? 1 over x. So since the basis, and here originally it can be power 1. So now from here, since the bases are the same, we equate the exponent. So it implies that minus 1 over x equals what? Equals 3. So now from here, what do we do? So now what I'm going to do is equals to 1. Sorry, this is cancelled. Is to be 1 because we are equating the exponent. So from there, so if we try to take the reciprocal, we're going to be having minus x over 1 equals 1 over 1. So x will be minus 1 automatically. So we have x minus 1 to be the solution to this problem. Okay, so if you want to check, you can kindly check this, whether x equals 1 is the main solution to the problem given above, right? So thank you so much for watching. If you find the class very interesting, so do not hesitate to subscribe to our YouTube channel, hit on the bell icon so that you'll be notified anytime we upload a new content. Thank you for watching. Bye bye.